In this video, I'm going to be going through what binary coded decimal or BCD means. So, BCD, before I go on, I highly recommend you watch my video on binary. Because otherwise you have no idea what I'll be talking about throughout this video. So, BCD or binary coded decimal is binary numbers that have each individual digit in a decimal number coded into it. I will explain further, or you'll be able to see what I mean with an example later. But before this, I want to do an exercise that's going to open your eyes, okay? So here we got some numbers, decimal numbers, 2, 4, and 9. And I actually have a task for you. Can you take these numbers and convert them into binary? You can pause now and try for all three. Alright, let's start at number 2. I'm going to use the hand method with my right hand, and I'm just going to start. And I note that 2 is actually 1, 0 in binary. Now I'm going to use the same method for the number 4. And I find that I'm pointing the middle finger, and that is 1, 0, 0. And now with 9, I'm going to use the finger method again, the hand method. And I find that I'm pointing 1, 0, 0, 1. Okay, it may not look like it, but all these three binary numbers have something in common which you might not be able to see. What they have in common is that they can all be represented by 4 bits. Meaning, if I add 2 more zeros here, 1 more zero here, this is a 4-bit number, this is a 4-bit number, this is a 4-bit number. Another similarity, another similarity with all decimal single numbers is that you can only represent them with 4 bits. Let me prove this. Can you try to show the number 8 with 3 binary bits? 8 in binary is 1000. But with 3 bits, you cannot put 1000. You can 000 or 100. It's wrong. What I'm trying to say is, you must use 4 bits, or at least 4 bits, to represent every single decimal single digit. Why is this important in learning BCD? Because that's how decimal numbers are represented in BCD. I have the number 69 here, and I have 2 arrows pointing out. I have a task for you. Can you find what is the number 6 in 4-bit binary and the number 9 in 4-bit binary? You can pause here. Okay, I'm going to use the hand method for 6. In 4-bit binary, we get 0, 1, 1, 0. And with 9, we already know from previously it's 1, 0, 0, 1. Okay, what's the point of finding this? The point is, we have our BCD number right here. 69, represented as BCD, is just these 2 4-bit numbers combined together. This is it. That is it. And that's pretty much the entire lesson. We can do a harder exercise, sure. Okay, let's say I have this number. Convert this into BCD. You can pause here. Okay, I'm gonna convert every single number into binary and put it in this text box here. 6, as we know from there, is 0, 1, 1, 0. 9 is 1, 0, 0, 1. 4 is 0, 1, 0, 0. 3 is 0, 0, 1, 1. 1 is 0, 0, 0, 1. I did that very fast because I just know the numbers. I didn't use any method, I just know. Okay, and now to get our BCD number, we combine all of these guys together. So we remove all the spaces. And that is 69,431 represented as a BCD number. That's the last example I'm going to give, because this is easy. A few more things you need to know about BCD is the advantages and disadvantages of using BCD over binary. The advantage of using BCD over binary is that BCD is much more easier to read. Much more easier to read. The drawback is that BCD takes many more bits to contain one number. Let's just use 69 as an example. In BCD, we have an 8-bit number, but in normal binary, I'm going to use the calculator method to get what 69 is in binary. We find that 69 is 1000101, which is 7 bits. So in BCD, we have to use 8 bits, but with binary, we can use 7. And this becomes more apparent in numbers like 17. 17 in BCD is 00010111. But in normal binary, it is simply 10001. This is 8 bits, this is 5. That is the drawback. You need many more bits to represent a number in BCD than you would need to have used in binary. And that is the advantage and disadvantage of using BCD over binary that you must know. And that is pretty much BCD. Thank you for watching this.